everybody, welcome back to Math Partake. So today we're working on another proof for geometry, and you see it right here. It says prove the following statement. If the distance from point P to point Q equals 1, then the ball that's centered at point P with a radius of 4 is a subset of the ball centered at point Q with a radius of 5. So quick definition alert. We're talking about a ball. When we say a ball, we're talking about an object that is a sphere, something that looks just like this right here. Just a ball. Also, another definition alert for subsets. The definition of a subset is basically that all the elements inside of a set are also contained inside another set that is larger than it. So think about something like, let's say, the spine and the body. Your spine is a subset of your body because all the elements that are located in your spine are also located in your body. Your spine is not outside your body, it's inside your body. So I have a note card here. I have a ruler. I also have a compass. And I'm going to use this to draw out the diagram before we begin. The distance between P and Q is equal to 1. Okay? So we're going to write a point here. We're going to call it P. And we're going to say the distance is 1. So my measurements, I'm not going to go by exactly a centimeter or exactly an inch. I'm going to go by half of a centimeter, just to make sure that it's going to fit on this note card. So we'll say from here to here. Okay. Let's say that's 1. This point is P. This point is Q. Okay. And that distance is, we're going to say that's just 1. Okay. Then it says that you have a ball centered at P with the radius of 4. So here's our P. Now we're going to use our ruler and look for a radius of 4. So again, we're going by half of a centimeter. So our 4 will be here. This will be our radius of 4. We're going to make a circle around this P that makes sure it touches this radius of 4. So let's do that now. This is our radius 4. Now we need to make a ball centered at Q. Here goes Q with a radius of 5. Let's do that. And our Q, again, has a radius of 5. We now have two balls. We have ball P, ball Q. Ball P has a radius of 4, just like you see here. And ball Q has a radius of 5, just like you see here. And the distance between P and Q is 1. So there's our diagram. Now let's start working on our proof. So the first thing that we're always going to start off with our direct proofs is a given and a show. Okay. Our given statement is the statement that is provided for us. So our given statement is simply located right behind the if statement in our example. So right here where it says the distance from point P to Q is equal to 1, we're just going to reiterate that. The distance from point P to point Q is equal to 1. And now just below our given statement, we're going to write our show statement. This show statement is the statement that we want to prove. This is located right after the then statement in our example. So we're going to write the ball centered at point P with a radius of 4 is a subset of the ball from center Q with a radius of 5. That's all we need for that. Let's go on to step 1 of our proof. So step 1, we're always going to start with our given statement, what we already have listed there, which is the distance from point P to point Q is equal to 1. And the way that we justify writing this in our proof is by saying, very simply, by given, okay? It was told to us. It's our given statement. It came right after the if statement. Let's move on to step 2. Now, we can already see from our diagram that the ball P is actually in the ball of Q. That we can already see, but we want to prove it. We're going to use an arbitrary point, okay? We're going to call it point X. And we're going to put this point X inside the ball P and see if it still lands in the ball Q. So let's do that. We're going to say that X is in the ball from the center point P to radius 4. And when that happens, I'll just put a so. So when that happens, that means that the distance from point X to point P has to be less than 4. Okay? The distance from any X that I put here, okay? Let's say if I just put an X here, for example. Because it's inside this ball P, it has to be less than this radius 4 because it's inside the ball P. And our justification for this step 2 is simply by the definition of ball. So now we're going to switch gears a little bit and use some information that you may already know. It's actually a formula that we're going to use to connect the distance that we have, which is this distance here from P to Q equal 1, and the distance that we now have just discovered, this distance from X to P, that must be less than 4. We're going to use those distances to show that the ball P is a subset. It fits directly inside ball Q. Now this formula is called the triangular inequality, okay? And quick definition alert, we all know that a triangle has 3 sides. But the triangle inequality rule is if you add any 2 sides of the triangle together, then the third side must be greater than or equal to the 2 sides that you actually added. So let's use that formula. Let's write it down in our proof and then make the connection. So here we go. Step 3. Here's our formula. The distance from X to Q, those are points, is less than or equal to the distance from point X to point P plus the distance from point P to point Q. And this is by triangle inequality. So imagine that these are all sides of a triangle. All right. If you add these 2 sides of the triangle, they must be collectively greater than or equal to the third side. By the way, if this video is understandable, please make sure that you like this video, leave me a comment, and subscribe to my page so you can get more videos like this that's going to help you in your math class. So step 4, this is almost like algebra in a sense at this point because we're going to use some substitution. So we're going to keep this distance from X to Q. Okay, and we're going to say that it is strictly less than 4 plus 1. And if you're wondering, where did I get this 4 plus 1? Well, the 4 comes from step 2, where we see that the distance from X to P is less than 4. Okay, we see that this distance from X to P now becomes 4. And then the distance from P to Q, we found that in step 1 because it was our given. This distance from P to Q equal 1 ends up being right here. And let's just finish this off with some addition. So the distance from X to Q is now less than 5. And just as we said earlier, this is by steps 1 and 2. So let's move on to our 5th step of the proof. Now, if you look here, we see that the distance from X to Q is less than 5. Okay. Now, because the distance from X to Q is less than 5, we can make somewhat of a notation conversion, if you will, that says that X is in the ball from Q, point Q, to radius 5. Okay? This and this mean the exact same thing. All we did was just change the letters around a little bit. And our justification is by step 4 and definition of ball. Let's move right on to step 6 of our proof, which is actually going to be our final line. If you look at step 2, this top part here, that shows X is in the ball from P to 4. And then if you look at step 5, that says X is in the ball from Q to 5, you actually see that we've gotten to the point where we've proven what we wanted to show. Okay? So this ball from P to 4 is a subset of the ball from Q to 5. The ball from point P to radius 4 is a subset of the ball from point Q to radius of 5. And our justification is what we just looked at by steps 2 and 5. And that's all she wrote. Like, comment, subscribe, and I'll see you next time on Math Partake. Hey, thanks for watching. For more answers and help that you may need in math, subscribe to Math Partake.